So when we were doing this on Friday, we were doing area between curves, right? So we would start with the top curve, subtract the bottom curve, find the bounds, do our thing, right? That's what we did. So that's when you have equations, functions that are y equals functions and equations. Most of what we see in this class is y equals, right? Or f of x equals, or g of x or h of x. So those are functions. That's why we call them f of x or g of x or h of x. They're functions, right? Today, we're going to see things, same idea, it's just we're going to see non-function things. It's the same idea though. So instead of y equals, you're going to see things that say x equals, okay? But it's the same idea with a little bit of tweaks. So when we find area, we're not finding area under the curve anymore. We're going from the right curve to the left curve. It's not top minus bottom for these guys. And then the bounds aren't left to right. They're bottom to top, okay? So it's a little bit reverse thinking what we usually do, right? We usually go, last week we did top minus bottom. What's the top? What's the bottom? Okay, subtract them. And then where are the bounds? Where does it start? Where does it finish? That's what we used to do, right? Or we will continue to do, but this is a special case. It's when we're doing things in terms of y. So we have equations that say x equals. First two equations, x equals for number 6, example number 6, okay? So that's when do you use this? When they tell you you have to use it this way? Or when the equations are x equals, guys. Sometimes they'll just give you equations and they say x equals. That's when you know you're finding it in terms of y. Okay? So same idea, just with little tweaks. Okay? Okay, so it's number 6. Find the area of the region in the first quadrant, so only the first quadrant, for the 3 graphs. Okay. First thing we're going to do, picture, right? Draw a picture. The calculator, your calculator will do x equals, but you have to solve it for y. You have to solve it for y first, because our calculator only thinks in terms of y. It only thinks in terms of functions. So to graph these two guys, or to graph the first two, we have to solve them for y. Okay? So I have x equals y squared. How do I solve it for y? Square root. Take the square root of both sides, right? Take the square root. Anytime we're solving and we have to take a square root, we have 2 answers, positive and negative x. Okay. That's that one. Next one, x equals y plus 2. Subtract 2 from both sides. You get y equals x minus 2. So the yellow and the yellow are the same thing. The blue and the blue are the same thing. The pink, I'm not worried about because that one already says y equals. So the yellows are the same thing. One of them is just in terms of y, one of them is in terms of x. This guy is in terms of y. This guy is in terms of x. Right? This guy is in terms of y. This guy is in terms of x. Okay? So we're going to graph these guys on our graph. Those are the 3 guys we're going to graph. Okay? Okay. So let's go to our calculators and let's get a picture. Okay. Where's calculator? Okay. Okay, so grapher. Okay, so the first guy. Plus or minus. Now there is no, as far as I know, there's no plus or minus button on the calculator. I don't think there is a plus or minus button on the calculator. So we have to graph this twice. Once the positive and once the negative, okay? So once positive, square root x. Once negative, square root x. Okay. So the red and the blue are technically one graph. Next one. Let's see, x minus 2. Okay. And then the last one was y equals 0, which is a horizontal line. So we got one horizontal line, one regular line, one diagonal line, and then the red and the blue are going to combine together to make one graph. Okay? So let's go see the graphs. So remember, we only care about the first quadrant. We only care about the first quadrant stuff. So I'm going to go to navigate a little bit so I can get a better view. And then I'm going to, remember, plus and minus, the addition and subtraction sign are the ones to zoom in and zoom out. Okay. Let's see. So the picture we're looking at is right here. Okay. That's the picture. So the red and the blue are technically one graph. So we're looking for the area bounded by all of them in the first quadrant. That is going to be, let me use this color. This area right here, the orange area here. Call it R1, or just R. Okay. That's the region we're talking about. Again, if you want to draw a sketch on your, usually when I do this without the calculator, I'll always draw a sketch. But since I'm doing this on the iPad, I can just do this. I always like to have something to write on because it helps me with the next steps. Is it required? No. But like I said, I always like to have something to write on. So we have to find the area of that orange R. Okay. Okay, so we're not doing this top minus bottom. We're not doing, so this one's in terms of y. In terms of y. Okay? So we're doing this right minus left, top bound minus bottom bound, or over bottom bound. Okay? So R equals, the difference here is this is not dx, this is dy, because we're in terms of y. So anything we put in to our equation has to be with respect to y, not x. Okay, the ones we put in my calculator was in terms of x. Anything that says y equals is in terms of x. Anything that says x equals is in terms of y. Okay? So, right minus left. So which one is going to be the right function? X minus 2. Yeah, on mine it's the green. The x minus 2, the green graph. That's the right. That's keeping, I always think about it keeping the shaded part in from the right side. If that green wasn't there, the shade would keep going, right? So when I put it in here, I'm not going to put x minus 2 like I graphed it. I'm going to put y plus 2 here. Y plus 2. Because this is in terms of y. It's the same line, but my graph, the reason I did these guys was because my calculator had issues with graphing. So I had to solve it for y. Okay? All right, so let's go to the other one. So we got the left side, the right side. The right side is here. What's keeping it in from the left? The red, right? The red is a part of the blue. The red and the blue are technically one graph. So that guy is here. Y squared. If you're solving this in terms of y, you don't want any x's in there because that's in terms of x. You want it in terms of y. Okay, done there. Now we have to go top minus bottom. So what is the very top of the shaded region? Yeah, there's a dot there, right? I'm going to make that dot right here. Let me choose a color that's not being chosen. All right, let me use black. That dot right there, right? That dot is at the very top, I would say. That dot is at 4, 2. And then the very bottom is the yellow, right? Yellow-orange, which is y equals 0. So the very top is this dot because it doesn't go above this line, and the shade doesn't go below that line. So we need top minus bottom, not left minus right. So we're not going to use the x's. X's are left and right. Y's are top and bottom. So we're going to put 2 over 0. 2 over 0. Done. The rest you can put in your calculator. Let's go back home. Back to the calculator now. Toolbox, calculus, integral, 0 to 2, parentheses, y plus 2. Well, calculator only has x's. It's okay. Minus y squared, close parentheses, 33.33333, which is 33 and a third. 33 and a third. So 33 and a third. I don't want to put 3.333333 unless it says to round. Did it say to round? No, it didn't say to round. So I don't want to put 3.333333 because that's rounded and it didn't say to round. So this is this, right? 3 and a third, which if you change it to a fraction, improper fraction is 10 over 3. That's the one I want. Unless it says round, it's probably best not to round. So 10 thirds is not rounding. 3.333 is rounding. Okay. And there you go. Okay. Very similar, but you're looking for different things. We're not looking for top minus bottom. We're not looking for left bound minus right bound. Now, once we had this picture, it wasn't very hard, right? That's the most crucial part. I think step 1 is the most crucial part because unless you have a picture, it's very easy to tell which one's the right and which one's the left. Where's the top bound, where's the bottom bound, right? It's very easy to tell those things. But until you actually saw the picture, you didn't know. Okay. All right, here we go. Example 7. Okay, so we have to, using your calculator, find the area of the region enclosed by y equals x cubed and x equals y squared minus 2. Okay? Well, one of them's already solved for x. The other one isn't. I have to solve this guy for x. So I take the third root of both sides. I get x equals the third root of y. I don't need a plus and a minus because it's third root. It's not square root. Okay? Okay, so the yellow guy and the yellow guy are the same. And then we have this guy over here. We're going to graph those now. Okay. So go to our graphs. Oh, forgot to solve this guy for y. I should solve this guy for y over here too. Because of my calculator won't do that. Forgot to do that part. So we're going to add 2 to both sides. You get y squared equals x plus 2. And then you're going to take the square root. Since it's a square root, you got to do plus and minus. Okay. So in our calculator, to graph it, we need y equals stuff. When we put it into the equation, left minus right, or right minus left, sorry, we put it into, we need x equals stuff. So it's kind of, you're going back and forth a little bit. Okay, so the first thing is picture. Let's get a picture of these two guys. So I'm going to go back to my graph. I'm going to delete the ones that I have. Go back to expressions. Just hit clear and it'll clear them out. Okay, first guy. Y equals x cubed. Oops, forgot the x part. That's squared. Okay. Next one. Y equals, so I need two graphs here, a positive one and a negative one. So just like I did the last one. Positive square root x plus 2. Negative square root x plus 2. So the blue and the green on mine are going to be the same graph. Red's a separate graph. Okay. All right, so now I'm going to go up to see the graphs. I'm going to go to navigate. Zoom in a little bit. There we go. So since I have an iPad, I can cut and paste or I can snapshot and stuff. If I didn't have one, I would be doing this on my paper. I would be drawing this picture on my paper because it's so much easier to see when you have a picture. Okay. So the area bounded. So it's a sideways parabola and then x cubed. X cubed is kind of that red Goes up, increases, then levels out, then keeps increasing. Okay. This one's dy in terms of y.
How did you label the expressions on the graph?
How do I label the expression? What do you mean label?
Or like, what would you write for this both square root of x plus 2's?
Right there.
Okay.
Mm-hmm.
What I found here is that how's it labeled? Because for me, it's coming up as like different. If that makes sense.
You just put it in exactly how it is, just like we did on the last one. Let me see if I can go back.
Oh, all right, thank you.
Okay. Okay. Navigate. Oops. Navigate. Okay. Okay, so we got right minus bottom. Or sorry, right minus top, right minus left, right minus left. So the right looks like the right, the graph that's keeping in the shaded part from the right side looks like it's the red, x cubed. Okay. So, but we're not going to put x cubed into our, because it's got to be in terms of y. So we're going to put the cube root of y. So the cube root of y. We don't want to put anything x related in here. We want to keep it in terms just y's. Okay. The stuff holding the graphs holding in the shaded from the left looks like it's the blue-green, the blue and the green, which is the other graph. Okay? We're going to put in y squared minus 2. Y squared minus 2. You should only have y's here. You shouldn't have any x's. Just like when we did it earlier, when this was dx, we didn't have any y's. We just had x's, right? You want to keep them consistent. Okay? Last thing to do. Very last thing is the top and the bottom bounds. The top and the bottom bounds. Okay? The top bound looks like it's here. The bottom bound looks like it's here. The top looks like it's 1 point something, comma 1 point something. Don't really know what that is. The bottom looks like it's -1, -1. We can check both of them. There's no need. It takes us about 15 seconds to check both of them. No need to guess. Okay, so let's go back and check. So if you're not sure how to do this, watch me. Okay? Because if you're trying to do both, if you're trying to punch buttons and look, it's not going to work. I'm going to go too fast for you. But just if you're not sure how to, if you don't remember how to do intersections, I'm going to do that right now. And this is also being recorded, so you guys can always go back and look at it. Okay? Okay, so here we go. Okay, so now I'm going to go to calculate. I'm going to calculate the top bound. That's the blue and the red. The blue and the red. So I'm going to choose either the blue or the red. I'm not going to choose the yellow, or the green. I'm not going to choose the green. I'm either going to choose the blue or the red. It doesn't matter which one you choose. And then I'm going to say find the intersections. So the calculator says there's 2 intersections with the red. There's one down here, which we actually want, right? We actually want that one. Not yet, but we want it. And then there's another one up here. So this one here is 1.215. 1.215. comma, 1.793, 1.793. And then the other one was -1, like we suspected. Since this is in terms of y, our bounds have to be y's, not x's. So the top bound is 1.793. The bottom bound is going to be -1. Okay. Hard part's done. Now we just put that in our calculator, and our calculator will give us an answer. So we're going to go back to home, back to calculation, toolbox, calculus, integral. We got -1 to 1.793, parentheses. The cube root is also in the toolbox. Anything that's not there, check the toolbox first. Okay, so the toolbox, I don't want calculus. It's on calculus right now. So just go back. Just hit the back button. And then go up to nth root. That's what I want, nth root. So we want the cube root of y, but we can only do x, so that's fine. Close the parentheses. Minus parentheses. Y squared minus 2. Close parentheses. Okay. Hit enter. There we go. 4 point. So we can't really, there's no exact version of that, so we're going to have to round. Like 3.3333, there is an exact, 10/3 is the exact version of that. There is no exact version of this. So we'll just say 4.215, 4.215, and that's it. And you're done. That's the only difference between, in terms of equations in terms of y. Okay. All right. So we have about 25-ish minutes. So we have two options. I haven't taken. I told you guys I'd answer questions. Does anyone have questions on practice 12? Were there questions on practice 12? If there were, we'll do that. If not, I'll give you an extra practice problem. So were there questions? Okay, questions on practice 12? We'll do that inside here. Okay.